Hi everybody, it's Mr. Denio. I just want to try my hand at making a video about the concept that you guys are learning. First and foremost, I hope everybody is out there happy and healthy and staying safe. And we're all stuck at home, so let's do our best to stay up with our understanding of what's going on. And I know it's a stressful time, so everybody hang in there, take care of each other, okay? Right now you can see I have before me a right triangle, okay? First, let's talk about the parts of a right triangle. Right here you have your legs, okay? Your legs are what make up your right angle. That's what makes it a right triangle. You have leg A, leg B, and yes, they're known as A and B. Now, that can be interchangeable. This could be A, that could be B. The reason is it depends on how we orient it. It really doesn't matter how you label the legs, either A or B, because when you do the Pythagorean theorem, you're just adding the squares, and the order doesn't matter in addition, right? So these legs are known as A and B. They form the right angle. Now this slanted side on a typically oriented right triangle or diagonal is known as the hypotenuse. I mean, it's a big word, right? Hypotenuse. Kind of fun to say. It is the side of the right triangle that is opposite the right angle. So here's your right angle. There's your hypotenuse, opposite that, okay? It's going to be the longest of the three sides of a right triangle because it has to bridge this gap between the two legs. All right, so it's important to be able to recognize your hypotenuse no matter how your triangle is oriented. So if it's like this, it doesn't look like it's slanted anymore, but you got to recognize that it's across from the right angle. Okay, so no matter how I orient this thing, I have to be able to recognize that the hypotenuse, C, is here. Okay, so it's often tricky for some students when they don't see a regularly oriented right triangle. Like right now, this might not look like a right triangle to some people, but here's your right angle, and there's your hypotenuse, okay? So always recognize that hypotenuse. Now, what's the purpose of Pythagorean theorem? Well, it really is to find the missing length to a right triangle. Now, how does it apply to the real world? Well, once you know that builders can actually use the Pythagorean theorem to create right angles. And when they lay foundations, they can go 3 this way, 4 this way, and know that if they go 5 this way, it's going to be a right angle in your corner. We don't want right angles in our corners in our buildings so that they're stable and strong. All right? So that's one application for that Pythagorean theorem. Other than that, it's just fun to know. Okay? Now this leg A, I made 6 inches, okay? And leg B, I made 8 inches. So using the Pythagorean theorem and just that information, we can know exactly how long the hypotenuse is, okay? So the Pythagorean theorem says I square A. So if I square A, and A is 6 inches, the square off of A is 36, because 6 squared is 36, okay? If I square B, the square off of B, which is 8 inches, is 64 inches squared, okay? Now, the Pythagorean theorem says I can add A squared and B squared to get C squared, okay? And that's going to be true. So when I add 36 and 64, I get 100. So 36 inches squared plus 64 inches squared equals 100 inches squared, okay? Now, how do we use that to find the side length of the hypotenuse? Well, the relationship between a square's area and its side length is the square root of. So the square root of 36 is 6, the square root of 64 is 8, the square root of 100 is 10. Okay, so right here we have this Pythagorean triple, 6, 8, 10. The reason why it's called a Pythagorean triple is because all your side lengths work out to be whole numbers, which is not always going to be true. Okay, so if you look at the first Pythagorean triple, the reason why I don't start with it is because a lot of kids are going to think that the next Pythagorean triple is just going to go in order, right? See how the numbers, they go in order? 3 squared plus 4 squared equals 5 squared. Well, that's only a triple because 3 squared is 9, 4 squared is 16, and 5 squared is 25. Okay? It works with the Pythagorean theorem. When you have A equaling 3 and B equals 4, C is always going to equal 5. And this is that triple that a lot of people use in construction. Okay, a side length of 3, a side length of 4. Well, the diagonal has to be 5 for it to be a right triangle. So if I ask for the next Pythagorean triple, not everyone's going to talk about the 6, 8, 10, which is the next Pythagorean triple. Some people might think, oh, these go in order, so the next one must be 4, 5, 6. Well, if I have A being 4 and B being 5, okay, let's figure out what C is. It's not going to be 6. If I square this, 4 squared is 16. I square this. 5 squared is 25. Well, the square off of the hypotenuse is going to be A squared plus B squared. So 16 plus 25 is 41. Well, that relationship between a square's area and its side length means this length has to be the square root of 41. The square root of 41. Well, you should remember that the square root of 41 is irrational with an I, right? The square root of 41 is an irrational number. We could only estimate it. The only exact way to write it is like that, okay? So it's kind of weird. You should know that this is between 6 and 7, but it's an irrational number. So it's kind of confusing that lengths can be irrational, okay? Think about the simplest square. If you had 1 square inch, okay, it's a sketch, so 1 square inch. Well, the area would be 1 inch squared, okay? A lot of people would think that the diagonal would also be 1, but the Pythagorean theorem actually shows us that it's an irrational length. So if I take this apart, make it just a right triangle, the side length's a 1, okay? 1 squared, well, we know that's 1. 1 squared, we know that's 1. So 1 plus 1, that's 2. And so that makes this length the square root of 2. So the diagonal here in a 1 inch square is actually the square root of 2, which is irrational. Okay, it's somewhere between 1 and 2. All right, so that could be tricky for a lot of kids. They might not understand that. Okay, so the only other thing that could be tricky with the Pythagorean theorem is if you're missing a leg length, okay? So we know this leg is 6. We already know the answer to this question because we just did it. But for an example, if we don't know what B is, okay, we know what A is, we know what C is. Well, since it's A squared plus B squared equals C squared, in this case, you're going to do C squared minus A squared to get you B squared. So, well, what's 100 minus 36? That would be 64. So the square root of 64 is 8. Okay? And that's basically everything you might need to know to be able to do this. If you have any questions, feel free to reach out to me. If you want to contribute anything as far as videos go or anything like that, or anything you discovered when you were doing this, feel free to do that. Other than that, I do miss teaching in the classroom, and hope you guys are all doing well. I'll try to upload a video every once in a while when we get a new topic going. All right, everybody take care, okay? See you later. Bye.